Hello everybody, this is Dr. Christopher White, and in this video we're going to begin by looking at how do oil and natural gas deposits form. So oil and natural gas are typically referred to under the umbrella of petroleum. So what is petroleum? Well, petroleum is a mixture of chemicals which are classed as hydrocarbons. And hydrocarbons, as the name suggests, consist of both hydrogen and carbon. And so in order to form hydrocarbons, we are going to need a starting material which is rich in those two elements. And by far and away, the most common starting material is going to be organic material, so life. So how are we going to take that organic material and produce oil and gas from it? Well, the first thing we're going to need in order to make oil and gas deposits is we're going to need an environment which is very rich in life, because it's going to take a lot of organic material to actually form that oil and that gas. And so we're going to be looking at environments which are rich in both plants and animals. So you might think of environments maybe like reefs, or you might think of environments like swamps, like things like the Florida Everglades. And so these are the types of environments where you have large amounts of organic material. However, there is a slight problem. Under normal conditions, when a plant or animal dies, its body will decompose. So in order to allow time for the organic material to become incorporated into the sediment that will eventually produce the oil and natural gas, decomposition needs to be inhibited. So we need a way of stopping it. And that is done through low levels of oxygen. So we not only need an environment which is rich in organic material, we also need an environment in which that organic material can then enter an oxygen poor area where it can be preserved and it can become incorporated into sediment. So if we go back to our reef here, well, under these circumstances, is that going to be helpful to us? Typically no. Although it's a very organic rich environment, it's typically very well oxygenated. And so this means that the chances of actually being able to preserve that organic material within the sediments of the reef are actually pretty low. Instead, what we're going to need is we're going to need environments like swamps and deltas, for instance. In those environments, you tend to have bodies of water within them, which can become quite oxygen poor, and as such, any organic material that falls into them will be preserved because of that lack of oxygen. We are also going to be looking at environments on the continental shelf, so in the oceans, or maybe at the shelf break, where the continental shelf turns into the deep marine environment. And in these situations, what we're going to have is we're going to have a buildup of oxygen poor seawater right at the bottom, where the ocean essentially meets the seafloor. And so in both of these situations, we're going to have plants and animals living. Those plants and animals are going to die, and their bodies are going to fall into this body of oxygen poor water, where the organic material will be preserved. It will become incorporated into a sediment, and that sediment is going to be the basis of us forming oil and gas. And so in terms of the types of material, the organic material which is going to be producing this oil and natural gas, we are primarily looking at two sources: microorganisms, which are very small microscopic life forms which live in water, or plants, which, as we know, are going to be quite rich in quite prominent in environments like deltas and swamp environments. And so along the bottom here, we can see the basic steps we're going to require. The first thing is we're going to require an accumulation of organic material to build up within a layer of sediment. And of course, that buildup is allowed due to oxygen poor conditions. The layer of organic rich sediment is then going to become buried. As it gets buried deeper, it's going to be exposed to higher temperatures. And once it eventually reaches a sufficient temperature, this is going to lead to the organic material being converted into hydrocarbons through the process of maturation. So what's the main source of organic material which forms oil and natural gas? Now, the vast majority of oil and natural gas deposits form in marine environments, so in oceans and seas. You can get oil and natural gas deposits which form from land-based environments, so swamps and deltas. However, these deposits tend to be much smaller, and as such, they are less economically significant. So the vast majority of large, economically important oil and natural gas deposits are going to be related to marine environments. And the sediment which is going to form our oil will typically contain anywhere between 0.5 and 2% organic material by weight. And the vast majority of this organic material within these marine environments are going to be organisms like this. These are our microorganisms, our microscopic marine life. And they live in a range of different conditions. Some of them will live right at the top of the ocean surface. Some of them will live within the water column itself and they'll just float around. And some of them will live on the seafloor or within the seafloor sediments. And so when these microorganisms die, they are steadily going to float down and they're going to end up on the seafloor within the seafloor sediments. And of course, if that area of seawater just above the seafloor is oxygen poor, decomposition will be hindered. And over time, the organic material from these very, very small microorganisms is steadily going to build up and up and up. And it's going to become incorporated into the sediment. And so over time, even though we're dealing with tiny, tiny organisms, you need to remember they're going to be dying in numbers of millions every day. Slowly but surely, they're going to settle into the seafloor, become incorporated into the sediment, and that sediment is going to become more and more organic rich. So now we have our source rock, which is between 0.5 and 2% organic material by weight. And so this is going to produce a range of different organic rich sedimentary rocks, but by far and away the most common is going to be something which is referred to as a black shale. And black shales, as the name suggests, is a shale, so it's a mudstone, and it's black because it has quite a high organic content. And so this is going to be a great starting material for forming oil and natural gas deposits. And so as that layer of sediment gets buried deeper and deeper within the sequence of sedimentary layers, it's eventually going to experience higher temperatures and pressures. So it's going to become heated. So as the temperature increases, we are going to see the organic material begin to change into a new material called kerogen. And kerogen is the solid form of hydrocarbon. So we haven't got a liquid and we haven't got a gas yet. We now have a solid precursor material, which we refer to as kerogen. Now, if that layer keeps getting buried deeper, it's going to experience higher temperatures, and eventually it's going to reach a temperature of around 90 Celsius. And at this point, we are going to see a change of the kerogen. It's going to break down, and it's going to form a liquid, which we refer to as oil or crude oil. Now, if the layer keeps getting buried further, it's going to be exposed to even higher temperatures. And at around 150 Celsius, we are going to see a change of this oil or crude oil from the liquid state to the gaseous state. And in this case, we have now formed natural gas. So as you can see, the formation of oil and the formation of natural gas is dependent on the temperatures to which that organic rich layer of rock have been exposed. So the technical name for this layer of rock from which the oil and gas is being generated is the source rock. Okay, so the next thing we need to think about is, well, what's going to happen to the oil and natural gas that's formed? So we're going to have our source rock. It's going to be heated to a sufficient temperature, and this is going to allow oil and natural gas to be developed. Now, oil and natural gas are relatively light compared to water. And so if you have a source rock, which is in contact with a permeable layer of rock nearby, the oil and natural gas will exit the source rock and they will move into that permeable layer of rock. So in this case, we can see that we have a shale here and a shale here, and they are overlain by layers of some kind of clastic sedimentary rock. So for argument's sake, let's just say a sandstone. And so the oil and natural gas is being generated from these two layers of mudstone, and then it's moving out of the mudstone into the overlying permeable layer of rock. Remember, Permeable means you have a lot of pore space, a lot of void into which that oil and gas can move. Now, because the oil and gas is naturally quite light, it's going to want to rise. And so it's going to try and find the highest point it can within that permeable layer. So if we look at this particular structure here, you can see we have an anticline. So we have the oil and natural gas being created by our mudstone, our shale. The oil and natural gas enters the sandstone, and because the oil and natural gas is so light, it naturally rises up to the highest point it can, which in this case is the hinge of the anticline. Now, you can also see in this diagram down here in the bottom right, we have a situation where typically this sandstone layer is going to contain quite a lot of water within the pore spaces. And so as the oil and natural gas enter the permeable sandstone, it's going to push that water out of the way, and the oil and natural gas is going to rise up and float on top of the water. And so if we think about this layer of sandstone here, what we actually have is a portion of it will consist of water within the pores of the sandstone. Then above that, you would have a portion which would be rich in oil within the pore spaces. And then above that, you would have an area with the even lighter natural gas within the pore space. Now, another interesting thing is in this particular instance, you can see that this layer of sandstone is capped by this next layer of mudstone, which is stopping the petroleum from going anywhere else. However, if we look at this layer of sandstone here, what we have is a situation where we have oil and natural gas being generated by this light grey layer. It is entering this sandstone here, and it is rising, and in this particular layer actually intersects the Earth's surface. And so what's going to happen in this situation is the oil and natural gas is going to exit onto the surface of the Earth. Now, the natural gas is just going to go off into the atmosphere. In the case of oil, though, we are going to see that oil coming out of the surface of the Earth as what we refer to as seeps. And a good example of a seep would be the La Brea tar pits in California. And so that's it. So that's how we form oil and gas. That's the starting materials we need to make oil and natural gas. And that's a basic overview of what happens to the oil and natural gas once it's formed. All right, thank you for watching and enjoy the next video.